Hello, shipmates. This is Chris Kreitline, your friendly open ocean navigator in celestial navigation. My email is celestenav@yahoo.com. Search on YouTube, C Kreitline, for all my videos. Always happy to hear from me. If there's anything in this presentation you don't agree with, or you think is wrong, or you're uncertain about, don't hesitate to contact me. I always enjoy hearing from folks with regard to celestial navigation. I'm also the author of Simple Celestial Navigation by the Heavens Made Easy in its third edition. This book is available on Amazon and Celeste Air. And you might catch me at the Annapolis Boat Show where you can pick it up. Now, what are we going to do? We're going to look at the sight reduction process to a fix. I did this 2 days ago. It's the intercept method of reduction of planets, stars, and moons to a fix. I'm going to show you where I made a mistake, how I found my mistake, and the final result. Now, full disclosure, I was at anchor when I did this, and the conditions were very calm. So, don't think that I get this kind of result every time, because I don't. But I like to go out and just anchor, spend the night, do some celestial nav, and enjoy the evening out on the boat. Okay, so let's move on over here to what I did. My DR position, universal time, I shot Venus, Jupiter, and then I shot Vega. All right, here's the standard form all filled out. You can go in the book and see what all this stuff is. Hopefully you already know a lot of this. Here's my actual degrees reading HS from the sextant with the correction for my height of eye. Then I have to add a little correction for Venus, come up with my HO. Then you take the time of the sight and you get into the nautical almanac and start extracting the information. You come on down until you get your local hour angle. Then you have your assumed position, your declination of Venus, and the local hour angle. And that's what you use to go into Pub 249, the sight reduction tables, to get your HC. I know I just zipped through all of that, but hopefully you know what I'm talking about. If not, once again, get into the book. Now, I did all of this. I got my intercept and I plotted it, and it was, well, I didn't know it. I thought it was okay until I did Jupiter, and then I knew there was a problem. It didn't come close to my assumed position. So I said, well, something's wrong. So I went back and reviewed everything. And I got down to right here, the GHA, the Greenwich hour angle for minutes and seconds. I had copied down the wrong numbers. Well, you know, anybody can do that. I'll blame it on my Beneteau, because the light over my navigation table shines from the right, and I'm right-handed, so my hand, casts a shadow on the pubs, on the books. So anyhow, I ended up writing down the wrong number. I made that correction and had to redo a lot of it, and then plotted it out, and it looked much, much better. I then did Jupiter, same process, tried not to make any errors, came on down, and got my intercept on that. Well, then I tried to shoot Halt. By the way, here are my actual readings, my HSs. Here's Venus, the time, and the HS. I'm sitting in my cockpit with my little digital watch set to Greenwich Mean Time. And so I record the time and the shot, Jupiter, time, and the shot. I tried to shoot Halt here, and clouds, haze, I lost the horizon. I I couldn't do it. I couldn't get it down. I couldn't find it to bring it down to the horizon. Couldn't see. Anyway, so I had to cancel that one. And a little while later, well, I see here it was about 40 minutes later, I looked up and Vega popped out. And I had a good horizon for Vega. So I did a shot of Vega. And then much later, like 2 hours later, I shot the moon. But we'll get to that. Anyway, Vega's problematic. Why? Well, I use HO 249 right here. And HO 249, the site reduction tables, stop at north 30 for declination. But Vega, if you look here, is north 38, 48, almost 39 degrees north. So you can't use HO 249. Now, if you have HO 229, which are 7 heavy volumes, you know, you're on an aircraft carrier or something, okay. But I'm on a little sailboat. I don't want to haul those things around. So I just used 249. But I shot Vega very clear. I worked it all down here to go into pub 249, but I couldn't. It doesn't match. Well, not a problem, my friends, because I have this form that I made up. And this is available from me. I don't believe it's in the book because I did all it after the book was published. But I have this form. Send me an email at at yahoo.com, and I'll send it to you. Anyway, what it is you're using the actual trigonometric formulas down here to figure up your HC and your ZN. But it's very easy. You have a calculator. Here's the data. Use the whole declination of Vega, 38, 48, 24. Plug it in here. You get the sign of the declination, the sign of the latitude. You just step through the form. And I have a video on YouTube on how to go through this. But you just follow the form, like I always tell my students, follow the form. Be careful when you're punching this in and when you're reading it off your calculator. These are all 4 digits. So you just work through the form, and when you come down here and it gives you HC, it's actually very simple. You just don't want to transpose any numbers. Then you take the HC and you start the process again, a slightly different process, and you come up with Z. Then you look at the little memory aid here to work up ZN. So it's just like your own little site reduction tables for shooting Vega or anything north of 30 degrees declination. So I put that down here. So I've got 3 things to shoot. Okay. I plotted them and they looked pretty darn good. I'll show you in a couple minutes. But then the moon came up in all of her silvery glory, very bright, I think just past a full moon, and cast such a strong glow on the water reflection that I had a horizon. So I shot the moon, and this was at 0100. I mean, it was very dark. That's Zulu, of course, but it was very dark. But I used the reflection of the moon on the water and shot the lower limb. A lot of people don't like to shoot the moon, if you excuse the joke, but personally I do. It's a little more challenging, a little more to it, but it's all in my manual. You just step through the form. You know, it's got specific things for the moon here. You get down to the same AP latitude, declination, and LHA as you would with the star, and go into pub 249 and derive your intercept down here. So it's really not difficult at all. After you do it a few times particularly. All right, so now I've got all the information. It's time to plot. So what happened? Well, I plotted them. And like I said, I can't say I'm always going to do this, but you'll see here all the lines of position crossed right here at that point. I can be pretty certain that's where I'm at. A little off from my DR, but that is a dead reckoning spot. So what's important is where these lines of position cross. Like I said, I rarely ever have anything like that. Usually there's a little triangle down there. But this time with the water being calm, sitting on the bay, not moving around, although it was starting to get very rough as I was doing all this out there in the bay. Anyway, that's how it worked out. I showed you there shooting 2 planets, a star, and a moon. And it took me about, I'd say, an hour and a half to do all that, particularly with my mistake on Venus, having to go back and look for it. I was able to do that. So if you have any questions about this, I'm very happy to answer them. I can hear my cat meowing up here. She's up here wanting me to give her something to eat, I suppose. Anyway, email me at celestenav@yahoo.com with any questions. Love to hear from you. There's that mangy little animal.